Hello everyone, my name is Anishana and you are watching Kubernetes web series. In this video, I will tell you how to use network policies to manage network traffic between pods. Network policies topics I will going to cover. What is network policy? Understanding the CNI. CNI stands for Container Network Interface. Then we will check how we can isolate the pods. Then benefit of labels in network policies, anatomy of network policy, and in the end we will proceed for lab and exam preparations. So let's proceed for our first topic, that is what is network policy. As we are aware that whenever we are going to working on production Kubernetes cluster, then we have to manage more and more application onto it. It is possible that these applications will have to communicate with each other, or we want to apply some sort of restriction on it. Let's understand this through 3D animation. This is our cluster. We have one Nginx pod and one SQL database pod. On Nginx pod, we have created an ingress rule. Ingress means incoming traffic rule, which allow only pod 80 traffic. Also, we created egress rule. Egress mean outgoing traffic rule to allow exit traffic only for 3306 port number. On SQL port, we created ingress rule to accept traffic on port number 3306. Now we have one user who want to access this Nginx port by requesting example.com:80. We have ingress rule which allow this request, and then this port write some data on SQL port by sending traffic on port 336. Egress rule we also allow. SQL port accept this request because of Nginx rule. This is what we are doing on firewall, right? For pod, we create an ingress rule to allow example.com on port 80, and for egress rule to allow outgoing traffic on port number 3306, and in the end we deny all the traffic. For SQL, ingress rule to allow traffic, deny all other traffic. Achieving communication between applications is really one of the fundamental objective of a microservice architecture. Most of this communication will be done through network, and the network is being managed by firewall. Kubernetes has its own implementations of network firewall called network policies. Hence, all these rules we can create with the help of network policies. This is a new resource kind we are going to discover. What we understand from the previous example that if you want to control traffic at IP or port level, then you may consider using Kubernetes Network Policy. Network policies are an application-centric construct which allow you to specify how a port is allowed to communicate with various network entities. Here, entities means endpoints or services. Network policies can be applied on three things. The very first one is IP block. When IP-based network policies are created, ingress or egress rule, we define policies based on IP block CIDR ranges. CIDR stands for class inter-domain routing. The second one is ports that match the selectors. We will use port selector in the manifest file for ingress or egress rule based on each port labels and selectors. In the last, we will use namespace. Namespace selector. This is what we are going to use inside the manifest file to grant access to specific namespace. In short, we can say that with the help of these three things, IP block based on IP range, while when defining a port or namespace based network policy, you can use selector to specify what traffic is allowed to and from the pod. So in short, we can say that we can create network policy based on IP based pod or namespace. That's it. No worries, I'm going to explain each and everything in my coming slide. So just listen theory part. Network policies are implemented by network plugins. You will need to have Kubernetes cluster with a CNI plugin installed. CNI stands for Container Network Interface. CNI plugins are generally not installed by default on Kubernetes. We have to install it after creating the Kubernetes cluster. Creating a network policy resources without a controller that implement it will have no effect. Now you're curious about what is network plugin and CNI plugins. Let's understand what is CNI. The Container Network Interface CNI is a common interface used for networking when starting kubelet on a worker node. CNI doesn't take care of networking. That is done by network plugin. CNI ensure the pluggable nature of networking and make it easy to select between different network plugins provided by the ecosystem. There are multiple network plugins are available. As per your requirement, you may select the network plugins. By default, the directory for some plugins are etc cni net.d, but other plugin may have different plugins, so you have to be take care of that. I'm using Calico, which is CNI plugin. Calico-kubeconfig file taking care of authorization of Calico plugin, while 10-calico conflict is the actual configuration file that the Calico plugin is using. In short, we can say that for the understanding purpose, we can say that these are the network plugins. Different network plugins are available in the market. You can choose whatever it is required. For me, I'm using Calico. This is the official documentation of CNI plugin. If you want, you can explore inside this github.com container networking /CNI. Let's proceed further. This is the configuration file of a Calico. For your information, a configuration file describe cluster, user, and context. Kind equal to config, server is 10.96.0.1. If I'm executing psaux grep API command, I will observe same IP range on option service-cluster IP. Here it is. Further, a certificate authority is this. I have reduced the line so that I can capture everything here. In the user section, we have defined name equal to Calico and mentioned the token it uses. In the context section, we have again name and context local and user is Calico. That's it. So let's move forward here. As I said, if I'm using kubectl get daemon set minus a is for all namespace, grep Cali, I will observe that there is a daemon set created for this Calico name. As of now, we have 3 nodes, so we have 3 pods running. If I'm executing kubectl get pods minus and kube system minus o void, I will observe master worker node 1 and worker node 3. And this is the basic principle of daemon set. Whatever the number of nodes you have, it will create the pods same as it is. Network policies are implemented by network plugins. CNI plugins are generally not installed by default on Kubernetes. Creating network policy resources without a controller has no benefit. This is what we have learned. When we create the Kubernetes cluster with the help of kubeadm init, we execute these commands, right? And after that, you should now deploy a pod network to the cluster. You can use kubectl apply -f this as the YAML file that I used when I created the Kubernetes cluster at that time. When I created the Kubernetes cluster, I had not described this thing because it's a totally different topic. For that reason, I just kept for this. So now you can understand that why we are executing this command at that time. Let's move forward here. Minikube integrated with Calico, which is a CNI plugin with network policy support. By default, there are no restriction to network traffic in K8s. Thus, port can always communicate even if they are in other namespaces. Or we can say that if no network policies are used, all traffic is allowed. To limit this, network policy can be used. If in a policy there is no match, traffic will be denied. Network policies do not conflict, they are additive. If any policy or policies apply to a given port for a given direction, the connections allowed in that direction from that port only. It means if you apply the policy on ingress direction, that will check the traffic for ingress only. It will not check for egress, exit traffic. Now, how we can do port isolations? It means how we can restrict the incoming or outgoing traffic of ports. Port isolation can be done by two ways. The very first one is incoming traffic, isolation of ingress. Ingress means incoming traffic. Remember, in equal to incoming traffic. Now let's suppose we have two ports. When I say ingress, it means incoming traffic. See the direction here. The second way we can apply the isolation is outgoing traffic. Isolation of egress. Egress means outgoing traffic, and remember E equal to exit equal to outgoing traffic. In this 3D diagram, we can see that egress, it is going outside here. It is going outside here. This is my user. It sent the request to on port 80. It will forward the request to second port. Here, the color coding green is for outgoing traffic and the orange color is for incoming traffic. I hope now you understand the meaning of ingress and egress. It is very important in terms of Kubernetes. Isolation doesn't mean blocking off all traffic. It means some restrictions are applied. They concern what connection may be established. Non-isolation direction, ingress or egress means that no restriction apply in that stated direction. By default, a pod is non-isolated for ingress or egress. It means that all inbound outbound connections are allowed. Now let's explore the benefit of labels in network. We had already covered the label topic. If you haven't watched that video, I must recommend you to watch that video. So let's explore the benefit of labels in networking policy. Label selector we will use here. We have four YAML file of ports, kind equal to ports. Now we have different names, label demo 1, 2, 3, and 4. Now in the label section, we have environment equal to pod, tier equal to API, app equal to Nginx. Here it's a pre-pod, API and Nginx. This port is for pod, but this is for DB and MySQL. This is for pre-pod, DB and MySQL. It means we have two type of application. One is for web application, the other one is for DB. And one is for pod and one is for pre-pod environment. Match label. If I use this blank, it means it will match all the pods in the manifest file, like here. If I use match API tier equal to API, then it will select these two ports. Why? Because it match this label. Let's suppose if I use tier equal to DB, then it will select this port, these two ports only. I hope you like my animations. I'm just learning these animations. Let's move. Anatomy of network policies. What is the structure of network policy YAML file? We have one pods on which pod rule to be applied thanks to label selector. Direction, in which direction we are going to apply or we create the rules, ingress or egress. These are the pods and these are the pods which are for outgoing traffics. And the last one is rule. What rule we are going to create? Ingress, who can connect to these ports, and for egress, where this port can send traffic. So let's understand. First, we are going to create the rules on it will apply to which port. So this port section will specify that this rule we are going to create it will be apply on this particular ports. And direction, in this port it will be apply ingress or egress or both. And rule, what rule we are going to create? It will accept all incoming traffic or it will accept only port 80 or 3306, whatever we have defined. Again, for egress, if we define for egress, then it will apply for the outgoing traffic. We will explore more, don't worry if it's not clear yet. This is our network policies. API version is networking.k8s.io/v1. Kind is network policy. Under the metadata section, we have specified name and namespace. Here I use default just to show you. Under the specs section, we have port selector. It means ports on which rule will be applied. Here we haven't defined anything inside this curly braces. It means that it will apply on all the port on this namespace. But here I'm using default, so it will apply all the ports which are created or which are running inside this default namespace. Next is policy type direction. In which direction, ingress or egress, we want to apply the restriction. In the last section is rule. It means that we haven't applied any rule on both direction. It means that all ingress and egress traffic will be blocked. There is no deny policy we implement on network policy. We just apply the rules to allow the traffic. Whatever we have not mentioned, it will be denied. Whatever we are allowing, that will be only allowed. Okay, let's move to further. In this manifest file, again we have select all the ports. In direction, we have mentioned only egress under policy type. It means that this network policy is only for egress traffic. Further, nothing is specified under egress. It means that we are blocking all egress traffic, not for ingress traffic. Why ingress is not allowed is not concerned, because in this network policy we have not mentioned anything for ingress here. And if we want to block all the ingress traffic, then we can use like this only. That's it. In the initial theory part, I have mentioned that we can apply network policy rules on the basis of IP block, port selector, and namespaces. We have already using port selector. Thus, let's start with port selector at rule section. This is our manifest file where we have already covered API version, kind, and metadata sections. In the specs section, we use port selector. Under this, we have mentioned match labels app equal to web. Now this policy will apply only those ports which has this label set. In the direction section, we have mentioned egress and ingress. If you notice, we have not mentioned any rule under egress. It means that all outgoing traffic will be blocked on those ports which has app equal to web label set. However, for ingress, we have one rule set. using port selector. In this section, we are allowing port which has label app equal to db can send the traffic to port which has label app equal to web. Let's understand with the help of this 3D animation. We have port 123 which is having a label app equal to db, and the other ports we have 123 and label is set to app equal to web. Now in this section, what we have defined app equal to web, it means that this network policy we are creating for these ports, right? And here we have defined ingress. Now this ports will accept the traffic which has label set app equal to db, like here. So it can send the traffic here to web app. But this port cannot send any traffic outside. Why? Because for the egress we have not defined anything. It means all egress are blocked. I hope now you understand how we can create the network policy and where we can apply these things. Don't worry, we have more, so it will be clear gradually. Let's take a real life example. We have three different type of ports. Port which has label tier equal to frontend can send the traffic to the port which has tier equal to db. However, tier equal to db port must not receive the traffic from the port which has label tier equal to backend, right? Now we are creating a network policy for the port which has label tier equal to db. How we can do this? Just adding this port label in the port selector field. We have already covered this. Understand policy type. We use ingress only. It means that this network policy will be only for incoming traffic. Have you noticed that all outgoing traffic are allowed? What happens if we want to allow only specific port then? And one thing more, you need to understand that here it will select TB equal to DB. So this port will apply this network policy. And for ingress, we have allowed only tier equal to frontend. It means that by default, it will reject all the traffic which are coming from tier equal to backend. Why? Because we have only allowed traffic which are coming from tier equal to frontend level only. Now you can see here ports on which pod rule will be applied here. And for direction, we are using ingress and rules allowing traffic only for from these ports only. I hope now it is clear, but I will make sure that at the end of this video, you will understand all the network policies rules. If we want to allow only specific port like 3306 from port which has label tier equal to frontend to port which has label tier equal to DB and deny port number 80. What we can do here, we can write a network policy for port tier equal to DB. Why we are writing this only for this port? Because we want to apply rule on this port only, right? Under ingress rule, we use port labels and also port number, which we want to allow. Here we have mentioned port selector, it match environment equal to prod and tier equal to frontend. This labels it will match here. And now we have again mentioned ports 3306 and protocol is TCP. It will accept only port number 3306 and it will decline all other ports, not only 80 but all other ports. Now one can understand here, let me remove here. What we can take from here, that if we not mention any port number, it means that it will allow all the ports. But whenever we are applying a single thing, it means that you want to specify only that port number only. So let's move further. Now let's suppose in this manifest file, we have two rules, rule number one and rule number two. It uses OR operator, not AND operator. In simple word, we can only allow traffic through network policies. Thus, any rule matches, it allow traffic. In short, we can say that whatever we want to allow, we can mention it, and whatever we are not mentioning, it will deny. You cannot specify that, okay, I want to deny this rule or this 80 port number should deny. You cannot do in this network policy. Okay, now let's take another example. Let's suppose we have two namespaces, monitoring NS and database NS. In monet, we have pods with label set tier equal to monet, and in database NS, we have pods with tier equal to DB. If we want to enable the ingress rule for database pod, then we have to write manifest file like this. It match tier equal to DB and ingress tier equal to monet, but it will not work because pod selector does not select pods from other namespaces. It means that we need a new kind of selector to choose pods from other namespaces. Here we use namespace selectors. So let's explore this one. Remember, this is what we discussed. We have covered pod selector. Now it's time to discover namespace selector. This is our manifest file for network policy. If I'm using old example, I'm trying to create network policy to allow incoming traffic for port TB equal to DB. One can notice in this manifest file, I'm using namespace selector instead of port selector. Under the match label, I'm defining label that set as namespace label. It means that I'm allowing all incoming traffic which are coming from monitoring NS namespace toward ports which has label tier equal to TB. In some scenario, we only need to allow specific ports instead of all ports for this namespace. In the same manifest file, we need to add port selector section just under the namespace selector section. It means that we only want to allow ports traffic that has tier equal to monet label set. Please bear in mind that if we add the port selector in separate array, then it means that it contains two elements in the from array and it allow all incoming traffic from namespace which has label tier equal to monitoring and also add all incoming traffic from ports which has tier equal to monet label but on same namespace, that is database NS. So just to summarize here, this namespace selector, it has come inside this array. It means that it will select tier equal to monet pods and it will drop the traffic which are coming from pod equal to tier equal to web. Why? Because here we have mentioned pod selector. You can read this rule like namespace selector should be tier equal to monitoring, that is here, and then the next check is this pod should has label tier equal to monet. If we have not mentioned this thing, then it will allow all the pods. But if we use hyphen in the front of port selector, it means that these are two different rules. Okay, like here, port selector match label tier equal to monet. Then it means that The first match is for namespace selector, the second one is for port selector, but this rule will apply to this database NS. Why? Because we are creating this network policy inside this database NS namespace. I hope it is clear now. As of now, we have completed ports and namespace selector. Now it's time to explore IP block. So we can create ingress, egress based on IP blocks. We can use IP block to allow the IP range. In this example, we are allowing 10 series IP range /24. It says ingress traffic from IP block CIDR range. That's it, simple. Here, only in the IP block section, we can use except. It means that it will deny this. This feature is absent on port label selector and namespace selector. In next, we have ingress IP block, and again we are defining the ports like we did previously for namespace selector. Here we are using ports, and in this example we are using range. Protocol is TCP and port 32,000 and end port is 32,768. So between all these ports are allowed here. If we want to specific allowed only one port here, so we have this one ingress and specific only one port. It means that from these IPs except this, if port are requests are coming from 3306 incoming traffic, it will allowed only. Now it is very easy for us. We have completed port selector, namespace selector, and IP block, allowing traffic specific port or range of ports. This is all we did for ingress. As of now, we haven't completed for egress, right? Next section is egress. And the good thing is that all rules will be same for egress, but we need to apply at egress section. Let's explore one by one. This is my network policy. Here we specify ingress and after that we have hyphen from. Now for egress we are using to. It means that traffic going towards, right? So you can write, you can remember this one. Port selector match label D app equal to TV. It means that these network policy will be applicable on app equal to web labels, and it will allow the outgoing traffic to app equal to DV ports only. Let's suppose we have two ports and the label of these ports are tier equal to frontend and tier equal to DB, and we want to forward all the traffic from tier frontend to tier DB. It means that we are going to create the network policy and it will attach to tier equal to DB, right? If we are creating ingress, but this time we are going to create egress. For that reason, we will deploy this network policy on tier equal to frontend port. As you can see here, port selector match label tier equal to frontend. After that, in the egress section, it means direction, we have mentioned 0. It means that all the egress rules will be allowed here. Let's take another example. Same, we have two ports and we want to forward only 3306 traffic towards tier equal to DV ports. What we can do here, in the manifest file, we will attach the tier equal to frontend same as it before. Under egress 2 and then port selector, we are matching this ports, and then ports section we will define port equal to 3306 and protocol is TCP. That's it. We have one port and we want to forward both the traffic to these two different ports which are having different label sets. In the egress rule, to namespace selector match label tier equal to key equal to tier operator in value frontend and db frontend and db and operator equal to n. Here we are using match expression instead of match labels. We can also use this. I have already covered this match expression while doing labels and selectors inside this egress to and then namespace selector match expression tier equal to key. It means that these ports, these are the namespace labels we have set here. Okay, tier is the key and operator is in and values are frontend and db. Now let's suppose if we want to forward some ports, then what we can do here, egress to IP block CIDR IP address and then ports protocol TCP and then we can use the range of ports here. So let's proceed for lab and exam preparations. In order to proceed the lab, I have already logged in into my GitHub page. Here I'm going to click on Kubernetes repository. After that, if I scroll down, I need to click on 17 network policy. And here is the lab. If I click here, it says that we need to create a network policy name ABC-name in the existing namespace orange. Ensure that new network policy allow port and namespace core. It means it is saying ingress to connect to 9000 port number of port in the namespace orange. This we will discuss at the end of the question. Okay, so let's understand this question here. The main thing I just colored network policy name is ABC-name in the existing namespace orange, and here namespace is core and it should connect to 9000 of the port which are running inside this orange namespace. So let's understand with the help of 3D animation. We have two namespaces, orange and core. In core, we have one pod running, that is core-pod1 name, and the label we have set app equal to core. Inside this orange namespace, we have one pod running and the label is app equal to orange and it should connect to 9000 pod. Also, there is another pod running which is app equal to orange. How we can write the network policy? In the API version, kind equal to network policy. Inside this metadata, we have mentioned ABC-name. This is mentioned in the question. In the existing namespace orange, so here I'm use namespace equal to orange. In the spec section, we have say pod selector match label app equal to orange. It means that this network policy will attach to this pod. Okay, and this is what it is mentioned in the question pod in the namespace orange. Further, policy type is ingress. As I said that it is saying that it should allow the traffic. It means incoming traffic should be allowed from the core namespace. It means that we have different namespace. For that reason, in the ingress rule, we have mentioned namespace selector match label as this. Where we can get this label? If I execute this command kubectl get namespace orange hyphen hyphen show labels, I will observe that this label is set when we create the namespace. I will show you in the lab. In the end, under port section, I have mentioned protocol TCP and port number 9000. Why 9000? It is mentioned in the question. It should allow only 9000 and rest of the other ports should be denied. Let me switch back to our GitHub page. Before proceeding this lab, let me tell you that when you do lab at home, first you need to create the lab setup, right? Same thing I'm doing here. First, I'm going to create two namespace, orange and core. Let me copy here. Before executing this, let me create one directory, any random you can use. I have created two namespaces here. Let's create three pods, one in core namespace and two on orange namespace. Here I'm using Nginx image. Inside this orange namespace, I'm going to create one pod and setting this label app equal to orange, and the name of this pod is orange pod 1 and here pod 2. Paste over here, copy this one. Now I'm going to create the third pod that will be created inside this core namespace. As you can see here, this core namespace, and the label I'm setting here app equal to. Now we need to create a Nginx configuration file and open the port 9000 instead of 80, right? Either I can go inside the pod and then modify the file, but here I'm just creating one file on my local machine and then I will copy this file into the pod. This is the easiest way for me. Here what is I have written here, copy this configuration file on the container. Syntax of the below command would be kubectl minus n namespace. cp is the command, localhost file path, and then pod name colon container path where I want to copy this file minus c container name. In my case, the container name is orange-pod1. You can check at your side if you use different name. I just copy here and then paste it. OK. Create one new file that will be used as a Nginx web page with the customized message orange pod 1 web server is up on 9000. This is my index.html file that I'm using here, and the same file I have mentioned in this configuration file here. Again, I need to copy this file into the pod. I need to copy this file, sorry. Okay, and then I need to reload the services at the end. Whenever we do any configuration changes, we have to reload the Nginx services. This is what I did from the sitting at the host machine. Same thing we will do for the second pod on orange namespace. I have already created this pod. Let me check if this is, yes, I have already created this pod. So let me copy, create one new file for this and second web page file, index.html file I have created here. And now it's time to copy both file into the pod. After that, I need to reload the Nginx services, clear the window. Now let's check the IP address of these ports. It is this. One is spawn on worker node 1 and the other one is created on worker node 2. Perfectly fine. Here I can see the labels also of these ports. You must able to connect from orange port 1 to orange port 2 or vice versa. From orange port 2 to orange port 1, I'm using this command here. Why I'm using this command here, let me show you here. And then curl, let me copy this here. From port 2 to port 1 IP address is this. And then colon 9000. It is orange port 1 web server is up and running fine. Here, for the sake of easiness, I just created one command so that you can use here. Okay, and the same thing I can use for port 2 and I'm executing from port 1. It says 2222 port are open. Port which are running on orange namespace can be accessed from the core namespace. Let's try. For the core namespace, I have not modified anything here because I am just going to check from core to orange. Here I am using core namespace and it will be executed from core on 9000. It is say up and it is 2222 is also accessible from core namespace. Now we have created the lab setup as per the question and it's time to solve the question. Let's create the network policy. I have already described all the context of this. Let me click the window here and then create the network policy. Now you should able to connect to Orange port on port number 9000. This is the syntax it should be. Now I need to copy here and it should work here. Here I need to add one syntax here, port 1. Now port 1 is up and running fine. If I'm using the same thing for double two, it should not work. Let's see. And it should connect to double two port number. Here I'm using connect timeout equal to 3. So I will get the timeout message after 3 seconds. Here you can see that my network policies is created successfully as per our requirement. In fact, you should not able to connect to Orange port 1 from Orange port 2. Let's check here and it should be timeout after 3 seconds. Yes, I'm not able to reach here. The reason behind is that we have applied the network policy on this port app equal to Orange, right? Although it will be applicable on this port too. Here in this, we have mentioned that ingress will be allowed only from name selector from core. It means that it will accept only the traffic which are coming from core namespace plus only from 9000 port number. That's it. And other incoming traffic will be dropped. Now go back to our original question. In the last statement, it is saying that does not allow access to port which does not listen on port number 9000, does not allow access from ports which are not in namespace orange. Now I hope you understand when we are going to create the network policies. Now it's time to clear the lab here. So I'm just going to copy all these commands here and paste it over here. Clear the window, ls space ltr, no files are there. Okay. Now let's go for the second question. There was a security incident where an hacker was able to access the whole cluster from a single hack backend port, backend 0. To curb this situation, Kubernetes administrator asks you to create a network policy called port block-np in namespace project app. Okay, it should allow the backend 0 port only to connect from the frontend port on port number 8080, connect to Nginx port on port 9090. Use the app label of ports in your policies. After implementation, connection from the backend port to the toolbox port on port should not work. For an example, no longer work here. Okay, let's create the setup of our lab. Also, it would be helpful to you to set up your own lab for the exam preparation. Here it is asked to create the project lab. Okay, and then create a frontend port with the label app equal to frontend inside this project app namespace. Further, I'm going to create a configuration file which will allow 8080 and the index.html would be frontend-index.html. Okay, so let me create a new file here. And also I'm going to create a customized message. When it will be accessible, we will observe this message. Now going to update one new configuration file here. It is for frontend pod and this is for Nginx pod. Again, a Nginx web server will be up if it's accessible on port 9090. For toolbox 3333 and again a web page for index.html page. Okay, now going to create Nginx pod, then toolbox pod, and then backend 0 pod. All are in the same namespace. If I use show label -o wide, I will observe 4 ports are running and the labels are app backend, app frontend, app nginx, app tool. Okay. Now we need to copy the files. Let me proceed one by one. Frontend and then reload the services. Frontend is completed. Now it's time to nginx pod configuration file, index.html file, and then reload the nginx web page. Okay, perfectly fine till now. It's time for toolbox. And then reload the toolbox pod webx services, nginx service. Show wide, we can also check again. These are the IP addresses. Now let's check if I'm able to access on this port 9090 or not. Here I'm getting 9090. Yes, it is accessible from the toolbox server. From the toolbox, why I'm checking from the toolbox? It should be nginx, nginx, nginx. It is up. In the first command, I'm using nginx. You can change it. Okay. And the backend, I can use backend here. From the backend, I'm checking nginx pod. It is 9090. It is up here. All these are up. Right now, I'm going to create a network policy. What it will do? The name of the network policy should be np-backend and it should be created project app. In the spec section, we are using port selector match label app equal to backend. It means that it will apply on backend port. Okay, let me check one thing here. Now it is good. Name should be np-backend and the port selector app equal to backend port. It should allow the backend 0 port only to connect this, only to connect. So we can create the egress rule here, right? In this question, it is demanding that backend 0 port can connect to other port. It means whenever it is trying to connect, it will send the traffic, right? It will not receiving the traffic. For that reason, I'm just going to create the network policy on this port. This is the reason I'm using app equal to backend label. So it will attach to this pod. And egress rule, I have already explained you why we are using egress here. In this egress to port selector, what it says, connect to the front-end port on port 8080. It says front-end port on port 8080. Port selector match label app equal to front-end port, front-end port on port number 8080. Again, I'm using ports, protocol TCP and port number 8080. This is my first array. In the second array, it is my second rule. It should also connect to nginx port. For that reason, port selector match label app equal to nginx. Again, port number 9090 here. Use app label of port in your policies. This is what I'm using app here. And rest of the other port, it cannot send traffic. Copy and then paste it over here. Clear the window. Okay. So I'm just checking here from the backend. I can connect to all these 3 ports so that I can compare it. from the backend port, I can access all three web ports. Now I'm going to apply the network policy, and after that it should connect only these two, not this one. Let's verify here. Yes, it is able to connect. It is able to connect, and we haven't mentioned anything inside the network policy for this port, right? Here you will observe timeout messages after some time. It is taking too much time, so let me close this command here and use this option. Connect timeout 3 seconds. Now you will observe after 3 seconds it is timeout. It means that it is not able to reach this here. Now how to clear the lab? Let me copy all these stuff here, clear the window, paste it over here and hit the enter button. Now from the today topic, it is clear that why we are going to create the network policies to replace the firewall. I hope you like this video, and if you like this video, please share, like and comment if you have any question to this video. Thank you very much. Bye bye.